How did Sherlock solve a crime using math? At the crime scene, Sherlock spots the tracks from the culprit's bicycle. Which way did he go? Left or right? See the two tracks? One is formed by the front wheel and the other by the back wheel. To know which way the bike went, we first need to know which track belongs to which wheel. Can you tell? Sherlock realized that the answer lies in the design of the bicycle itself. Its front and back wheels are connected, so it doesn't matter how the bicycle moves. The distance between them is always fixed. Plus, you can only steer the front wheel and the back wheel follows it. Imagine that the wheels are at this much distance and these nails trace the path of the front and back wheel. This is how the tracks would look. I'm only moving the front nail, but since the back one is attached, it follows while maintaining a fixed distance. If I make big waves with the front nail, the back nail makes similar waves, but smaller in size. The same is true for a bicycle. You can try making any random path. The one with the larger variations would belong to the front wheel. So that's how Sherlock knew which track belonged to which wheel. But how did he figure the direction? For that, let's assume and imagine the bike moving in a particular direction, say left to right. This is how it will move. And what if we assume the opposite direction, right to left? This is how the bike will move now. Notice something weird in this case? This distance between the front and back wheels keeps changing as the bike moves. And that's not possible. The distance between the wheels should remain fixed, as in the left to right case. That means the bike was actually moving from left to right. How do we figure this out without imagining the moving bicycle? First, we'll assume a direction, say left to right. Now let's try to place the bicycle somewhere on the tracks. For this, take any random position of the back wheel, say here. Since it is always directed straight towards the front wheel, we can locate the front wheel by drawing a line along this direction. That's called the tangent line, by the way. Since the front wheel should move on this track, this is where it will be. Next, we do this a couple more times for different positions of the back wheel. Now take a look at these segments. All are of different lengths. And that's not possible, since the distance between the two wheels should remain the same. So, this can't be the direction in which the bike is moving. Let's do this for the opposite direction now. Draw the tangent line, and here's the front wheel. We do this a couple more times. Measure the three lengths. This time, they're all the same, as they should be. So, this is the direction in which the bike was moving. And that's how Sherlock did it. Pretty smart. Time for you to help Sherlock. Let us know in the comments which track belongs to which wheel and did the cycle go left or right.